the, and muting my phone, with the introduction. So what we'll be talking about today is the update to watermark compliance, as you can see on the presentation there. So there's a current update to watermark of 2018, and we'll also be going through some other aspects. A little bit about Stormtech. So I'm Troy. I'm the Managing Director of Stormtech, and the business was started by my father in 1989. I've been involved since then. Dad invented the linear drain, the threshold drain as we know it now, and manifold drains. So a lot of patents and IP out there. We are an Australian-owned, Australian-made business. Everything's been made in Australia since we were established. All our products have watermark, and we seek to exceed the requirements, because the requirements, as we all know, are the minimums. And as such, we've gone for 316 marine grade stainless steel instead of the minimum 304. Given that, we can give a lifetime warranty on our products. And we are the only drainage company in Australia and the world to have a green tag certification. And further to that, we're the only green certified drainage company at all. Learning outcomes for this is I'm going to be talking about the code, mind-numbingly boring, but I'm going to try and summarize and highlight the important aspects for you. Let's talk about some practicalities and how to apply the knowledge and troubleshoot some problems from a design, from a product selection, and also installation aspects as well. And to able to create design solutions that will be able to be implemented in the construction. And we're also going to be able to apply the knowledge for best environmental outcomes. So I've actually got a little bit to talk about with that. So moving straight into it, WaterMark certification, and what is it? So the next slide here, lots of text. So the current iteration of WaterMark is 2018. That superseded the 2016 version. Some significant differences. Main reasons: 2018 introduced a material selection so that there was no confusion or interpretation of unsuitable or not fit for purpose materials. So I've highlighted aluminium here as an example. Now, aluminium is an awesome metal, but it does have its limitations, just like various timbers and so on. Aluminium is marine grade. You see it on boats and outside quite a bit. But when aluminium fundamentally is put into cement, concrete, buried in the ground, it can fail because it's only tolerant to a pH range of 4 and 8.5. Anyone that has a pool will be very familiar with the pH ranges of 7.2 to 7.6, and that's what our body likes. So cementitious products such as I write here, mortar, cement, concrete, tile glue, grout, bricks, they can initially generate a very high alkalinity of up to 13. That drops off within weeks to around about 10, but it doesn't go below 10. What this tells us is that 10 and the 8.5 of aluminium are not compatible. So aluminium needs to be separated from this alkaline solution. And it's particularly about crevice corrosion. So the Aluminium Council and the Australian Window Association released a technical bulletin which gave everyone insight into why this is an issue, hence WaterMark stepping in and updating the code to include a materials section. So anything specified to the WaterMark 2016 is no longer suitable and is not fit for purpose. So here's a little image to show you what I mean by crevice corrosion. So what happens is aluminium, tough as it is, won't stand up to the alkaline solution. So the alkaline solution on its own is not the fundamental problem. What happens is the stagnant water that stands behind and below tiles, so you've got your tile lines and so on, the grout glue, the water behind there becomes stagnant. What's stagnant? It's when it's deprived of oxygen. Once it's deprived of oxygen, then you have a either mild sulfuric or a mild hydrochloric acid solution. By mild, I mean very. You're not going to hurt yourself with it, but it's that rotten egg smell that you might notice from damp floors and so on. That's when you're getting an aggressive solution in there. Now what happens is that solution softens the anodizing of the aluminium, and any crevices such as joints and connections in there are then attacked, and it can be weeks, literally just weeks, before the aluminium begins to fail, and it's an expensive job to remove it. Aluminium gratings in, say, plastic channel and so on, they're fine, there's no problem with those. Moving on from that, let's have a look at some considerations for drainage in different applications like bathroom, laundry, and thresholds. So if we look at interior, interior areas, bathrooms obviously one of the more popular areas to personalize, particularly from a design perspective. From an installation perspective, it's also one of the more critical rooms to get right on there. So what are the really key considerations? How much water we're putting in and how we get that water out. Very simple, but the devil's always in the detail. So what we're going to do is a little introduction into Australian Standard 3500 in relation to drainage. So 3500 covers a lot of areas, but the drainage is what I'm going to focus on today because I'm the drain guy. Yay, good for me. So before we go into the code itself, where does the code get its information from? Now, I like to introduce people to this because AS 3500, the NCC, BCA, PCA, etc., all take their information from some very fundamental Australian standards and codes. I call them a foundation standard because it's what the rest of it stands on. 3500 takes its information from lots of different sources, and for this, we'll be looking at what's related in 3500, the current version, 3500 Part 2. Part 2 is the sanitary drainage section. 2018 is the current version. So we've got two real aspects in 3500 that we're going to be focusing on, and that's Part 4.6.7 and 13.17. 4.6.7 is about sanitary drainage, and Section 13 is about fittings and fixtures. Where do they get their information from? They take their information from AS 2887, waste and grates, and WaterMark. Where does WaterMark get its information from? It gets its information from 2887. Now, this is a very old document. It dates back to the 60s, and there's also some other aspects of it that we'll talk about now. So why is this important? I'll show you. So on the left, we have WaterMark WMGS 040 2018, which is the old MP52, and that does come from the 60s. AS 2887 is from the 80s and 90s, unchanged from the 90s. They've just done a bit of a text update to it. What I draw your attention to is the two tables, Table 1 and Table 3.1. If you can see it clearly on the screen, I realise the right-hand one's a little bit fuzzy. You'll see that they are identical. I want to point this out because it shows that WaterMark takes its info from 2887 and so does 3500. The information transferring through from the foundation to the current iteration is identical. And it's critical information for designers of drainage like me for the product side, but it's also important for yourselves to understand where this information comes from so you've got a better idea of what size suits what. So the water in the drain. So that's called the waterway. There are two aspects of the waterway in a drain. Firstly, the waste outlet connection of the waterway. So that's the bit that goes into the riser. Then it's the grating waterway, and these are different components. Linear grates, as I'm a specialist, obviously I'm talking about those a fair bit. Linear grates have a far larger waterway than the waste outlet. Now, when you're looking at the DN description, DN is the fitting outlet size descriptor, a linear grate has a large waterway. The outlet has a pretty much fixed waterway, so whatever is largest goes first, and the outlet always goes last. So if they're the same, then it'd be 50-50, but in this example, I've gone a 100 grate over a DN50 outlet. Here's a picture. So the DN for the grate. So you can see a linear on the right and a standard centre waste on the left. So the grating has a DN 150 rating, and in reality it's more like a DN 1000, but we limit it to a 300 mil length. You don't need to worry about that. That's for me to like to explain these little details. So you can see there are two DN 50 outlet wastes. So here's a different way to view the same part. They both have the same size waste outlet to connect into a DN 50 riser in the bathroom. But as you can see, the grate on the left, the standard grate, has a very small waterway compared to the grate on the right. So, fit for purpose. What is the WaterMark fit for purpose? Well, fit for purpose just means it's been tested, mechanically tested, physically tested, and dimensionally tested. Fit for purpose means, as best as we can tell, it's fitting to the minimum requirements. Let's not forget that standards are the minimum, not the maximum. It's accredited to the minimum requirements for plumbing safety. It's the old type tested that's been moved forward. Now, devil in the detail. The little jobby on the picture there is watermarked as a system, which means you can't use these components separately. You can't throw away that little grate and use that flange on its own. That it would be a non-complying construction method. And for those on the installation side of the presentation here today, watch out. You will be at fault for that mistake. And what that means is your building insurance will be void. So it's an area, I point this out because it's an area I've been involved in as expert witness on a number of jobs, and that has come out as part of the problem because it didn't work, either because the DN was incorrect or because the installation was incorrect, and they didn't use the system as it was intended. A couple of observations for you. Around the country, the standard is the same, but there are typical uses. So Queensland, 50 shower over a 50 riser. WA, it's 80, DN 80, which is very popular. South Australia, it's 80, but that's now in recent months moving more towards 100. Victoria, DN 50. NT, DN 50, but NT, it varies a lot. It depends on where the developer or the builder is from, and they use their own preferred method as long as it sticks to Australian standard. ACT is 80 is very popular, although again that's shifting to 100, and New South Wales is being 100. A little bit of information of why DN 100 is becoming more popular is just because it's cheaper than DN 80 on the piping side. The two waterways in a bathroom. So as I mentioned, 3500 Part 2, 2018 is where we get our code minimum requirements. I've already 4.6 for four waste gullies, and for the grating it's 4.6.7.6, and that actually speaks about linear drains and standard wastes. The other part, fittings and fixtures, 13.17 showers. I'll talk a little bit more about that because there's a difference between individual showers and common showers. For the code, 4.6.7, I'm not going to labour this too much, but it will be deemed as a fixture trap, which means it fits in Part 4 and Part 13. And prohibited location. So this is something for people to remember. Floor waste gullies shouldn't be installed in any cool rooms and air conditioned return areas. So that's more for commercial application, but it's good to know. And also those locations typically require a load rated grate because you're getting trolley, pallet jacks and so on, and trolleys going through there. So let's look at the removable grate aspect. So I mentioned that the code is the minimum, and on the right there you see the an extract straight out of the code, the current version, and you've got the riser minimum DN 80. So DN 80 is fine, and it relates to 4.6.7.6, and this diagram is one of the most useful to have to hand when you're designing or building a wet area, because it gives you not only the information about the grating, but it also gives you the distance limits for where your waste can be either trapped or untrapped. So in the diagram, you can see that an untrapped waste, you can't take further than 1.2 meters from the riser. And for a trapped waste, it's 2.5. So where it says a minimum DN80, as per the code here, typically you'll find in the eastern states, at least, it's more often now a DN100, and in New South Wales, it's been DN100 for quite some time. And that's purely down to price. But there's a practical aspect. There aren't many people that are in trade, plumbers I'm thinking of here, that can get their hand into a DN80 to clear a trap out. DN100, just about everyone can get their arm down about 300 mil to the trap. Now in the code here where it says the second sentence, where the sole function of a floor waste gully is to dispose of water spillage and wash down water, a minimum DN50 riser may be used. So again, I've been involved with the regulators on resolving some of these interpretations. Some years ago, that sentence was interpreted by many in the construction side that they can use a DN50 riser in the bathroom and don't need to have the minimum DN80. That is incorrect. Because the term wash down water, they are interpreting that as I'm having a wash. And even some regulators interpreted that as having a wash. That is not correct. It's literally if you're just wiping down the walls and giving the floor a quick wash. That's all it's meant to be. So that would be for like a powder room or something like that. You can go DN50. But DN80 is the minimum. And for a shower, you need to have a minimum DN80 riser coming towards it. And we'll go into that on the next slide here. So if you look at the top, again, a little bit fuzzy, I apologize for that. If the shower drain is intended to be the only floor waste in the bathroom, then it needs to be DN80, minimum DN80. DN100 is practically better. So what's that going to do to your design? Well, you have to make sure that the grating is at least the DN of the riser. Now, if you have a main riser in the bathroom that is in the floor but not in the shower, then you can run the shower with a DN40 waste. So you don't have to stick to a large grate in the shower if you've got another minimum DN80 drain floor waste in the bathroom. So we'll go on now to a little bit more on the shower side. So we're under fittings and fixtures, part 13 to 3500, and in the showers. So individual showers, here we go. They've repeated it. An individual shower shall be a minimum DN80 grate or channel grate, and shall be connected by an untrapped waste not smaller than DN40 to a floor waste gully. So that means the picture on the right here, or a trap and waste pipe not smaller than DN40. No, I've put the note in there for prefabricated shower bases. This is literally extracted straight out of the code, word for word, in accordance with manufacturer's instructions. So to the specifiers and to the construction installers on the session here, there's two things to bear in mind. You've got the code, which is the minimum, and then you have manufacturers like me, where we have our installation instructions. Now, when we're certifying or having a product certified, our installation instructions are also assessed, and they're determined whether they're suitable or not to achieve the minimum. So when you're looking at specifying and installing, it is critical to not only check the code, which is the minimum, but also to check the manufacturer's instructions. In those that have had waterproofing shenanigans, you'd understand that something like water-resistant plasterboard, no manufacturer actually says it can be used in a shower without it being waterproof. So little word to the wise there. Now here we come to shower groups. So we've just done individual showers, shower groups. So what's a shower group? It goes to a common shower, so common channel. Often shower groups go to common channel. And what is a common channel? That would be something like a gymnasium or a barracks, where you've got a linear drain at the end of the room, and you've got a whole bunch of open showers or shower cubicles all draining to a common channel. This next table tells you the size of the grate, so hence why I wanted to highlight to everyone that there are different DNs of the grate and the discharge pipe. So one shower, minimum DN 80 grate, and the outlet pipe is minimum DN 40, but you've also got, don't forget, the distances and the riser issues there. Now, if you've got 2 to 3 showers, same size grate, DN 50 pipe, waste pipe, and 4 to 6 showers, DN 100 grate, with a minimum DN 65 discharge pipe. Rule of thumb, what makes it easy to make sure that you're not only achieving the minimum, but you're not going to have any certification issues? Go with DN 100 on your discharge pipe and your grating. Unless the design aesthetic, you want to minimize the size of the grating, then you can take it down to DN 40 and you can have a disconnector gully. We'll talk about those later. So the practicalities. Do we need a floor drain in the bathroom? Well, not really. If you have your shower waste sized to suit the minimum DN 80 riser requirement, it is contentious whether you have one in the main bathroom floor, but it does solve design issues, and it's relatively cheap at the design stage to include it in construction because it's very easily costed for the builder. So you can have just one in the shower, and the shower can be used as a floor waste gully, but remember the code. Now we've got wall installations. I love putting my drains up against the wall. It's just some of the best look, and I've got some new product that we'll be releasing later in the year to solve that and make it look invisible. But I'll leave you with that tease and show you a nice little photo here. Where can the flange go? So AS 3740 interior or domestic wet areas, you need a flange, a leak control flange, onto your riser pipe. This is a really good example of what I see time and time again on a building site. Once that wall is constructed, you've got virtually no access to that drain, and the grating outlet has got to be severely offset. So that's something I've seen. I think we've all probably seen that. So just because it looks good does not mean it is correct. I like those photos. So here we have some of the quiz questions. So I'll just walk you through. Now it's important to understand the current iteration of WaterMark. It is 2018. Why do I say that? Why do I give you the answer flat out? It's because a week and a half ago, the ABCB released the 2020 version, and I have a 2020 version of this presentation. But they've rescinded it and they've reverted back to 2018 until they work out some technical issues. Is PVC a suitable material for sanitary drain? Of course it is. Now the minimum DN connection for a shower, I put that one in there to trap you because I've been talking about DN 100, but if you're connecting the shower from a main riser elsewhere in the bathroom, an accessible main riser elsewhere in the bathroom to the shower, or a disconnector gully, which we'll get to, DN 40 is the one. Yes, custom drains can be manufactured to size. That's what I specialize in. Floor waste gullies shall be installed with an accessible removable grate. Of course they should. How are you going to maintain it if you don't? Can you install a non-WaterMark sanitary drain? Trick there, the really interesting one there is the term sanitary drain. Stormwater does not have WaterMark. So it's sanitary drain. If it doesn't have a WaterMark, no, you can't install it. Distance from an untrapped waste from the riser. So trapped and untrapped. Trap has the water seal. That distance is important. I've seen many people get caught out by that if the regulator's on their toes. It's 1.2 meters. The minimum DN outlet for the trap or discharge pipe for a group of 3 showers, that'd be DN 50. Now, Back to the aluminium one, what's the highest pH that aluminium can withstand? I put that one in there because it's important to know, because it's got to be fit for purpose and you're not going to have your building insurance if you mix these up. It's 8.5. And the smallest DN, waste connection for a washing machine, we'll get to that because I'm going to talk about laundry separately. So, environmental issues. Let's talk about hair for a moment. Poor drainage selection will require additional maintenance. Jetters and so on, they really do put your drainage at risk. Some chemicals do have names like suicide, and they're just horrendous for the environment. The ability to clean a drain regularly will significantly reduce the requirements for chemicals or invasive maintenance, such as the plumber's eel. Hair is just, I mean, look at mummies. They dig them out of the ground after thousands of years, and they've still got hair, sometimes with the henna in it. Hair is about 60% of drainage problems. So it can and will persist in drains for years, and people have a lot of fun with their hair. And these are images from before the pandemic. So no, pandemic lockdown hair isn't unusual. We've just had some fun lately. Hair removal, two choices, mechanical or chemical. What's the problem with hair? 60% of shower blockages are from hair. Liquid fire is one from down the road, and it's pretty obvious how bad for the environment that would be. Sensible options. Obviously, I do linear drains, but a standard centre waste can do this as well. Reduce the hair at the grating. Use the grating as a GPT, a gross pollutant trap. Strainer grates are the most effective because you stop the hair at the surface, you don't have the maintenance issues. I've had them in my house for over decades and I've never had a hair blockage. Access for maintenance. So when we're designing, making sure that we've got access for maintenance is critical. Bearers and joists, you can typically get underneath it. Slab on ground, no you can't. Buried in the slab, having started out in the concreting industry, it always bothered me because your vibrator in the concrete can crack the pipe and you've just got one heck of a situation to fix. Above first floor plumbing, you can typically access it through the ceiling. Now, going back to the wall application, there's a specific requirement, and this will be coming up in the latest update to 3740. And we'll talk about disconnector gullies very shortly. So we've got here an image of basically a flanged channel that becomes your leak control flange connecting directly to the pipe, and your waterproofing is adhered directly to the tray flanges. As per the current iteration of 3740, these flanges must be a minimum of 50 millimeters. 20 mil is a tiling flange. And again, if that lets go, the building insurance is void. Make sure you do a 50 mil flange. This allows you to have the drain right up against the wall, be it a grating type or a tile insert type. So here we have disconnector gullies. What is a disconnector gully? A disconnector gully, as you can see from the table there, gives you a much greater distance from your fixture waste to the trap, to the gully. So we've got, I won't dwell on this for too long, but it is important to know that you can get an extension on these distances by using a disconnector gully. Now the laundry. Laundries can be as difficult as bathrooms, mainly from a waterproofing aspect, but the drainage is also critical because it's very basic drainage. You don't actually need a floor drain in a laundry, depending on the jurisdiction you're in. And foaming is a general issue for all drainage, but it's mostly an issue in the laundries, occasionally in the kitchens and the bathrooms. Depends on the hardness of the water typically. So here we have a quick summary, again, an extract straight out of the code. And you can see that you've got the connection distance to the gully, and it's pretty much identical to the bathroom one. Just wanted to highlight that for you. So the laundry code is pretty straightforward. So here's a bit of a summary. DN40 is the minimum connection. Most of the time, it's a DN50 connection because it's cheaper than DN40. Section 8.4 talks about your laundry troughs, and no trough or washing machine is to be connected directly to the stack, you use a disconnector gully. Those in the trade or those dealing with plumbers directly, they'll often call that a disco gully. And section 11.23.2, again, the minimum is DN40. And here we go to 13.25, clothes washing machines. Again, they're talking DN40, but the reality is most of the time it's DN50 as it's cheaper and easy to use. Laundry practicalities. So from a design perspective, the floor drain should be near the, if you're putting a floor drain in, it should be near the troughs and the washing machine if possible, because you are going to be typically doing a 1.2 or 2.5 metre connection to it. And if you have a floor drain in there, preferably should be near an external door. And generally only one floor drain is required in the laundry. Problems, foaming, as I mentioned, is a main issue. Insufficient drainage due to, now this is in the laundry, we're dumping our clothes on the floor. If you've got a centre waste, they can be blocked. And drain blockage in the laundry is generally due to the high use and debris from your clothes like lint, but you'll also find coins and paper clips and hair clips and so on in there as well. We've spoken about foaming. You can run it through a sud saver, so it's reusing the previous water. Extend the distance up to 2.5 to the main waste. For drains being covered over, a linear drain is a simple and elegant solution, because no matter how many clothes you put down, there's typically a point where the water can sneak into the drain, same as in bathrooms and floor mats. Oversize the drain to make it easier for access to cleaning, as I mentioned before. So it's very similar to the bathrooms. And again, disconnect the gullies, which could be on the outside of the building, make it easier to access for maintenance. Now, thresholds. Thresholds are something I've loved to introduce to the Australian and the world building industry. Why do we do level thresholds? It was mainly for the elderly and those in wheelchairs and so on. It wasn't meant to be a designer feature, but they do look good. If anyone's ever seen the movie The Party, that one's very famous property. You can still go and visit in Los Angeles, and they have a lot of level thresholds with no drainage. Apparently it's held to maintain. But there are some pitfalls with level thresholds. So we've got some nice images of various thresholds. So yes, we can custom fabricate curved ones if you need. They can be integrated with a variety of flooring services and just about any type of door. The code for level thresholds is mostly covered under the external waterproofing code 4654, and there's an aspect of the NCC. So instead of going through all the text, here's a picture of what that code intends. So your door track and your subsill are above and separate to the waterproofing. The drainage is outboard and lower than the subsill, with a level grading on top to provide your finished level surface. Now, P500 also talks about a level threshold, and as you can see, sorry, brain dead moment for a moment there, sorry about that. We need to stop water from entering the buildings. For design aspect, you need to slope the surface away from the door. Even though you have a drain at the door, do not slope towards the door. And the grading is there to take water away from the door or the window, not from the surface area. You're still going to have to slope it away. And then we've got practicalities of it. So a step down is normally how we waterproof the building to make sure that water from the outside doesn't make its way inside. So step down, that's typically determined by the terrain category. So a terrain category then 2 typically means a 50mm step down. And you can create that step down within the drain as per 4654. Most door and window manufacturers are now familiar with level thresholds, and they can accommodate a level drain for you. Obviously, they often come to us to do it for them, and other guys like me. Now, the drain component alters the sequence of construction. So when you're designing or when you're installing, you have to understand if you've got a linear drain or if you've got a level threshold there, then often the drain needs to go in at the threshold before the door track. And that can really cause some problems on the construction sequence and cause delay, which we don't want. Now, after the drainage, which is my area, I think what's more critical than the drainage is the waterproofing. So 4654 and 3740 are the two key codes to go and examine. Some door systems will require a full custom fabricated drain, but that's pretty easily accommodated these days. So problems, draft suppression is a major problem for thresholds, so just make sure that you do have the appropriate internal draft suppression for your sliding door that is not touching the drain or the door track. And insufficient allowance for drainage at the threshold does pose a large risk for damage to the internal finishes. So damp onto your timber floor is probably a good example there. So design solutions allow sufficient depth for the water to fall below the subsill. Key word in that sentence, subsill, because the drain has got to be typically about 30 mil lower than the subsill to allow for the volume of water in a 100-year rain event. You might need to look at how you're doing your footings to allow for a level threshold during design, or if you're doing a renovation, but also on the installation, it's not necessarily business as usual. It is critical to have all the stakeholders on a threshold engaged on this one detail, the builder, project manager, and possibly even the client in this aspect, because it might change what they expect. And ensure that you've allowed for plumbing to be in the correct position before installing the subfill. So, and you can achieve some beautiful results like this one. So, where does the water go? Typically, insufficient depth for the water to fall below the subsill is one I see a lot. Again, as I mentioned, the footings, again, it is a collaborative effort to get these right. As I mentioned, the plumbing's got to go first. In Sydney, stormwater is put mostly untreated, generally into the waterways, and it's about 500 billion litres that ends up in the ocean. That's about the entire Sydney Harbour in a year goes into the ocean. So filtering this water is incredibly important because it does hit the waterways and it'll improve the environment for us all. And using the correct grating will reduce the amount of debris getting in there. So wedge wire grates were invented to filter water from bores about 100 years ago. The best filter grates. So we investigated what the best filter grates. We went to a 2mm aperture grating. It stops hair, grabs hair really well. Also stops cigarette butts being ground through, and it does stop drinking straws getting pushed in and blocking up a linear grate. The AR series, they're pretty much the best gross pollutant trap for linear drainage. Despite the push for cheaper products, we've discovered that Aussies are pretty switched on, and it's still the leading grate in Australia. A little infographic, you can grab that from our website. Obviously, you can get off this presentation as well. So here we have some applications. We have bathrooms, we have the thresholds, as you've seen most of those. There are commercial solutions, so there aren't many drainage requirements, many drainage applications or aesthetic solutions that we can't provide. The bottom left, the drill core library in South Australia, were actually asked to produce a grating out of Creighton to match the facade of the building, which we did, and it does match the building. Thank you very much, everyone, for your time. I'd like to now open it up to questions. So for the initial questions, we've got, what, about 20 minutes left. For those that want to ask a question, can you use the raise hand icon if you know how to use it? If you don't, feel free to go open mic. Have I presented so well that there are no questions at all? We can talk about specific jobs if you have something.
I've got a couple of questions, people with their hands raised, Troy, so I'll move it to Susan.
Hi, Susan.
Susan?
Unmute your mic, Susan, maybe, if you can hear me. Maybe Sophie, if you can unmute the mic.
1 second. Oh, there we go.
Okay, sorry. Look, I came in a couple of minutes late, but great presentation. This is not so much focused on the technicality. I think you've covered it superbly. But my clients, domestic clients, constantly complain about the difficulty of removing those linear grates. I put them in all the time. I put your grates in to my specifications all the time. And it's not easy to clean. Is this something that you have had feedback on? Is it just something, you know, that they have to deal with? Do I warn them up front? You know, and my wealthier clients aren't doing it themselves. It's their cleaning people, and their cleaning people are complaining.
Yes.
What's your feedback on that?
Okay, we do provide a grate removal tool. There's no cost to it. It goes out with all the kits. If they don't have one, we'll more than happy to send it out to them.
Okay.
And a tip for the maintenance is don't try and lift up the grate in the middle, lift up the grate from one end.
Okay.
Because they can bind in during the installation. The wedge wire grates practically are the hardest grates to clean of our product range. And the easiest way to clean them is to remove them from the bathroom completely and let them leave them outside if you on the balcony if you're in an apartment. Let them dry out completely before you clean them, and then you can simply remove the hair by hand, and then a brush will take the rest of the hair off. That's the easiest way to clean them. The downside to that it is a two-step process, and you do need to let the grate dry out because then it stops the hair tangling back up on the surface tension of the water.
Oh, that is fabulous. Thank you very much. Thank you.
Okay, Troy, I've got another question here from Victoria. So, Victoria, you're welcome to ask Troy a question now. Sorry for the delay. I think it takes a while to unmute. Victoria? In the meantime, maybe Troy, I've got a question in the Q&A chat from Jessica Kyres. She's asking, how would you go about rectifying a non-compliant shower DN outlet size in a concrete slab on ground?
Okay, good question. It's one we get a fair bit. It depends on the incorrect DN context. So if it's if the DN size of the pipe in the slab is the issue, there's unfortunately no real alternative except to break open the slab and fix it. An alternate solution might be to use a disconnector gully on the pipe to the outside. That will give you your maintenance, and you can go 3.5, 5.5 meters, 6.5 meters, I think, depending on the DN side. So that slab on ground, if you can access under the slab or the main drain, that's as an alternate to breaking open the slab. If it's an incorrect DN size of the outlet in the drain, but your riser is the correct size, it's not so problematic, but you are going to have issues with repairing the waterproofing if that's been broken through. So if it's one of my PVC channels and it's straight over the top of a DN pipes, if you've got a DN 100 pipe in the slab and you've got a DN 100 channel over the top, but they've used a DN outlet over the channel, it is possible to oversize the outlet and make the outlet size match the DN size of the pipe. that can be done potentially without destroying the waterproofing. It is cheaper to redo the waterproofing than to break open the slab.
Troy, I've got a question from Victoria. She's asking, much of the details discussed relate to plumber being fully informed about the code requirements. In your experience, are most plumbers up to date?
No, they're not, which is why this presentation goes to master plumbers. We do a lot, because we invented the drains, because this didn't exist before we started fooling around with it. Education was the biggest part. How do we make it work? And informing trade, and so we support the TAFEs. We give them samples, we give them designer guides, we give them full kit and caboodle and do presentations to them. Plumbers typically forget the fixture unit ratings and so on things. So I like to simplify, like in the presentation, what are the core code requirements out of the standard, and my installation, as I mentioned before on the WaterMark, my installation minimum requirements cover what the plumber needs to know, and the installation is typically in graphical format because I know no one likes to read a whole bunch of text, so we try and do it with images as much as possible.
Another question here from Angela. Is your Creighton grading still generally available or only for large custom orders? And what was the name of the project that you used it on again, please?
Okay, it was I said it once and now it's gone out of it. It's the Drill Core Library in South Australia. And no, it's not for large custom orders, but there's a minimum material requirement for us to buy the Creighton. So it's basically minimum sheet requirement. Don't forget, Creighton, like a lot of metal finishes, is PVD, for example. Here's brass. So this is a 16-year-old PVD plated grating prototype that's still looking good after a lot of hard service. This is a fairly recent bronze. Now, these are meant to patina and age. So just like the Creighton, it is going to affect the adjacent floor surface, as in staying onto it. Sorry, PVD will not.
Troy, there's a few questions here about linear drains. First one is, do you need to use a linear drain to level threshold with timber or composite decking?
No, not really. I mean, if you've got a timber or composite decking and it's the subsill of the drain, I'll just see if I've got one here. This is a typical door track. This is a typical subsill. Has that part to it, so that would go in like that. This has holes in it for the water to drain through onto the subsill. So if you've got a timber or composite deck here, and this is draining freely below, then you will not live, because the point of a linear drain at a threshold is so that the drainage from here can be taken away into the stormwater system. So if you're draining through a deck, then no, you won't need a linear drain on that application.
And do you need to slope a linear drain in a bathroom floor?
No. I'll put a caveat to that. The bathroom floor needs a fall, minimum 1 in 80, or for small tile, 1 in 100 for the main bathroom floor. The linear drain itself So with the PVC channel, it has, very hard to see, it has a scribe line down the middle to guide the water to the middle of the channel. But the water will spread out either side and find its way to an outlet. Just the same as if I take my water and I pour it on my desk here, it's going to spread out around my desk until it finds an edge. The trick with linear drains is to make sure that they're level. Don't try and run it one way. Design consideration for bathroom, for example, would be try and have your drain opposite the door so that the floor is sloping all in one direction to your linear drain. And that stops, if you have it perpendicular to the door, then you may have a slope across the door. And that can just be annoying and not look so good, especially between the hallway and the bathroom threshold. Did that answer the question, or I can try again if that didn't?
We've got some thank yous coming in, so that's a good sign. Another question from Jin O-sun. He's asking, what is the main cause of the foul smell coming from the bath drain?
That will be bacteria, anaerobic bacteria eating the fats and the oils and nutrients that go into the drain. The reason the foul smell would be there because of unwashed areas within the piping, which is why we have a water seal on a trap. So your trap, if I just run the slide back to a picture of a trap, the trap will, I'll go back to the hair one. Oh, well, this will do. I'll just use that one. But you can see the trap below the drain there. The trap has a water seal. In Australia, the minimum water seal is 75 millimetres. Why is it 75 millimetres? It's because the water evaporates because it gets hot. If you don't have a drain being used frequently, that water will evaporate, and 3500 requires you to use something like a trap primer to drip water very slowly into that drain to maintain the water seal. If the water seal's gone, that will be the main reason for you to get an odour in your drain. That's the water seal serves two purposes. One is to reduce pest intrusion, although as we all know, cockroaches swim quite well. And two, it's the main one is for odour issues.
Cool, thanks, Troy. Last question I have here from Joanna. Can you please explain what a disconnected gully is?
Yes. I'll just swap my screen sharing. I'll just see quickly how I can go there. I've actually got that up on the screen. I wonder if I can just go out of full screen mode, and I'll go to a PDF. Where's the PDF? I'll do this as quickly as possible. I know we've got, there we go. Fixtures, disconnected gullies. Have to minimize that for a moment, everyone, sorry. Oh, come on. Disconnected gullies are fun things. Where are we? This is the fixture unit rating that plumbers always forget. Junction stacks. Tundish. Okay, we're getting very close to it now. Sorry for the discharge of floor waste gullies. 4.6. Okay. So that's a submerged one, and very close we get to. Okay, we're going to run out of time oh no, it's still got another few minutes. Okay, sorry, I'll find it correctly for you. Charging, floor waste gully riser. So this is straight out of the code. Inspection openings. Actually, I'll give you a shortcut. I'll just jump back into the presentation here and just run up to the drawing here again. So Oh, I had disconnected galleys now. Let me just see if I've. No, I'd rather show you the exact disconnector gully part. Or if I go here. Oh, here we go. Here is a disconnector gully. That might give you. I thought that question might come up, which is why. So if I just bring you here. Oh, goodness. Can everyone see this image here? Is that coming up on the screen for you guys?
I can see the diagram in the PowerPoint with the drainage consideration.
Oh, it's only the PowerPoint? Okay, I'll have to go back to that. So apologies, I can't show you exactly a disconnector gully, but if, can you see my cursor moving around on the screen?
Yeah.
Yep, okay. So imagine this isn't the main riser in a bathroom. Imagine we've got a big wall here, and this is inside the house where the 38 is, and this is outside the house. What you can do is you can have your drain inside the house going to the outside of the house to a gully outside of the house. So what I mean by gully is, this is some information I have internally for my staff, just to introduce them to some plumbing terms. So this is the gully. That is the trap, because the water sits between here and here, your 75 mil seal. And this part here is your riser, and it's only the top part. So see my drain there, that's the floor waste. So when people are specifying, they'll often say floor waste gully, which is the correct way to do it, because you're combining a complete system there. If you wanted to have a disconnector gully, what you would have is you would have the shower drain connecting to a gully with, it could be inside the house or outside the house. So technically that is a disconnector gully as well. But the reason for a disconnector gully, and it's actually what I've done in my own home many years ago, is I had the big drain, because I wanted to have small drains on the inside. I had a big gully on the outside that a plumber or myself, I can go in and I can maintain that without having to disturb anything inside the house. So I can rod straight through there, untrapped, and have it come out there. These don't have a seal on them on the outside. They have to have a grating, and you can't have them connected to the vent, and you can't connect it to the stack directly either. That's a big no-no. Does that answer the disconnector gully? Oh, time to wrap up?
Yeah, that's all the questions that we have for today, I believe. Troy?
Excellent. I hope you've enjoyed it, everyone. I have a passion for this sort of thing. And so if anyone's got a drainage question, just give us a call. The office is here. I'm obsessed with it. So it's kind of my life, sad as it might be.
Thanks, Troy. Thanks, everyone, for joining us.